Welcome to Thinkstop, and today is our first video in the series that I'm making is for the mainly focusing on the interview related questions. So in this we try to solve sliding window related questions mainly. Okay, so the concept that we are studying here is sliding window. Okay, so we'll try to solve easy to medium question from the LEET. Okay, because this is one of the concept that has been asked in the interview multiple times, and many good companies also ask, even the fan companies also ask. So this is a basic concept. So what we are trying to say is just trying to explain a concept what we want to apply. Sliding window is nothing but let's say you have an array. Example I'm giving, you have an element, let's assume x, y, z, x1, y1, z1. It will be given to you like either give me a subarray, right, where basically the sum should be maximum of that subarray. So give me that subarray. So how you try to find out? Subarray is the contiguous elements. Basically it's like a there is a one array and you need to find the set of contiguous element which will be part, you can't change the order, which will be part of the array. So it's like something like this can be one of the subarray, this can be one of the subarray, right? This can be one of the subarray. So you need to find that subarray which has the maximum sum. This can be one of the example for the sliding window. So now I'm just going over the problem from the LEET only, and we'll try to solve those two problems. One is on the subarray, another one is on the substring mainly, I think. So let's start with the first problem. Okay, so in this what we are saying is you have to minimize the subarray sum. So earlier I was talking about the maximum, but here it has been saying ki you have to minimize the subarray sum. Just trying to explain the concept here, right? So let's say the problem is minimize the subarray sum. So you have to find the array of positive integers with the minimum length of the subarray whose sum is greater than equal to the target. Okay, so this is the problem statement. So in short what it is saying is you have an array. So let's say 1 2 3 5 7 3 2 1. Let's say this is the array. Now what it is saying is basically, and your target is given 7. Let's say you have to find a minimum size subarray whose sum greater than equal target. This is the goal. So here what can be the minimum subarray? Let's say take this subarray for example 3 2 1 5. So it's a 6 but it's still lower than target. Let's take this is higher, 3 2 5 3 8, right, 10. So it's more. So this is a one of the subarray, but there can be other subarray like 5 3 also, right? Why not? So 5 3 is 8, so it's greater than, so 3 5 can be one of the answer of the size 2. But can we minimize further by looking at this? It's not possible because the single element is a 5 and we already reached the array size of 2. Okay, so this can be the answer. Now let's try to see from the how we'll try to approach this problem, right? So it's a simple thinking. Like let's say you have an array, right? This array only I'm talking about. So what you do in this case is you try to do the sum, like it's like your current sum, like for you'll iterate over the array and maintain a current sum, right? So current sum is like, let's say let's try with the index 1 still lower, our target is 7, right? And then current sum, if we go I equals to, this is 0, here I equals to 1, then your current sum becomes, let's say 3, right? I equals to 1, still lower than target. What we need is the answer, right? This is our goal, right? So answer is the one which we need to find, right? So yeah, so now we need to find the answer is which is the nothing but your minimum length right? So going back to the problem, target is 7 still, right? Now I equals to, we go to 3, right? So the current sum becomes your 3 to 5 6, still lower, you can't do anything, right? So your subarray, which is for the which we are following with the current sum, is a starting with a k equals to 0, we reach till I equals to 3. Okay, this is a k starting point for this subarray, right? Now reaching to the I equals to 4, current sum becomes 6 and 5 11, right? This is your current sum, right? Now k starting for this was k equals to 0. This is a one of the, so what is the length? It's like a I minus k, right? I minus k. I is, what was the I? 0 1. This is a 2. Sorry, this is a 3. So it's like 3 minus I minus k plus 1. So it's minus 3 minus 0 plus 1, which is nothing but a 4 length subarray, right? So this is becomes your one of the answer is 4. But at the same time, what you have to do is you have to minimize that subarray also, right? So how you will minimize that size? Because you have to find the minimum length subarray, right? So what we do is, with the I equals to 3, current sum is your 11 and starting point was 0. Here one of the answer you got is 4. So what you do is you minimize. So how you minimize? So basically initial array was this one, so we reached till 1 2 3 5, right? So the array was 1 2 3 5. So what you do, you start, once you find this answer, now what you do is you start basically squeezing the size of the array. How do we squeeze? Like you start incrementing this. Once you get over the sum, you just try to minimize it such that your goal is just greater than equal, right? So once it crosses, try to minimize till what point you can decrease, so that you get a like minimum length subarray which is exceeding the sum, right? So what you do is, you at a k0, now you increment k to 1. So now your sum becomes, you removed the 1, this is removed, right? So now 10, right? Still greater, right? Answer can be 3 because you removed 1, and I is still equal 3. Now you got a 3 size subarray, right? The answer is 3. Now you further squeezed it, the array from the starting point of the subarray to, now you move to the 2. Now you are at a 2. So now you move to the 2. So what you do is, this is the basically nothing but sum is 8, that is also greater than, answer is 2. Okay, because the size reduced, still this is more than equal target, and your I still becomes 3, right? So you squeeze the size of the subarray. So this is one of the answer you got. Now still it is more, so it doesn't make sense to increment I at this point. You further squeeze this, because it's when it will make sense once you have the basically lesser sum, so that you can take the elements which are beyond I equals to 3. Otherwise you need to squeeze the array till the point once it becomes lesser than your target sum, so that you can take the subarray which are upcoming subarray with the, once you increment I to further. So now your I becomes 3. So till this point only one element you are selecting, which is a 5. Now it's lesser. At this point in time your sum is only 5 only, and answer is 2. Now what you do this loop. This k is the squeezing part which is happening once you cross over the sum, right? Now what you do at this point is, you have to basically increment the I went to 4. So what was the fourth? So fourth is the basically 3, right? So your 5 plus 3, which is 8, I equals to 4, k still equals to 3, and your answer is 2. And this also is a 2 size subarray, because 4 minus 3 plus 1, so it's the same. So same thing. Now 8 still greater than equal, so you got it. Still you have to squeeze the I, right? So you have further squeezed the I to, let's say you further squeeze the I, okay, to I equals to 4, further squeeze the k to 4, and your sum becomes 3. this is sum, and answer is still equal to, right? So now you point to the you have reached the point to the 3, right? Now you have to go further. So now sum is 3, so now you go I equals to 5, which is nothing but the element of 3, 2, 1, right? So 3 we are already, 2, 1 is pending, right? So your sum becomes here 3 plus 2 equals to 5, right? That was a 2 only. Now k equals 4, I equals, and answer is still equals 2 because this is a lesser sum. Then last element is the 1, so you went to I equals to 6, sum equals to 6, and k equals to 4. This is not, you're greater than the target was the 7, right? So your answer final is 2 only, because 2 size subarray was a greater than your 7 sum, so hence answer is 2. And this is not making sense, so till the time it doesn't cross your sum, you are keep incrementing I, right? So let's see the pseudo code of this, which I've already written in the LeetCode. So let's move to that to understand. Hope you got the approach that I was trying to explain with a sliding window concept. So this is nothing but you are sliding the window. The squeezing part is nothing but you are sliding. You're sliding according to the basically I would say the problem that you are trying to solve, right? Your goal was to minimize the length, so you're like squeezing the length and till the point till when your condition satisfy for the target sum, right? So let's move to the basically LeetCode, where I will just show you like how I've written. So this is your answer variable, okay? So we'll just go, this is your answer, and current sum is always 0. Index is nothing but your k, which I was mentioning there, which is the subarray starting point it will maintain. And this num size is simple, so you are keep on incrementing in the maintaining the current sum of the subarray, right, from the starting point of the subarray, like which is nothing but your index, right? So this is the basically current sum plus nums of I. It's maintaining the current sum. Once it crosses target, you try to reduce, right? So once if answer becomes 0, then this is your answer length, right? And if answer is more, right, because the current sum is greater than, you minimize answer into I minus index plus 1. This is like a first time you are initializing it, okay? So that's where you have to go, and then basically when answer is 0, the first time you whatever the comes greater than equal, you make it keep that as answer, and else further for the further iteration you minimize the whatever is the existing answer with the I minus index plus 1. And this is the part where you are subtracting, squeezing. So your current sum gets squeezed because you are incrementing your index, which is the starting point of the subarray, and then till the current I, right? So that way you are able to figure out the minimum. So this is nothing but a sliding part, this one, okay? Yeah, I think that's all I wanna say here, and I'll just remove this part. I think this created a I think this was an extra bracket it introduced. Now it's fine. Let me just compile. So test case is passed. I'll just submit the problem. Later, let's see the where it passed. Let me just. So this is passed. Let's move to the next problem, right? So the next problem was you have to find the longest substring without repeating a character. Okay, this is another similar sort of problem that we are trying to solve. In this, what we are saying is basically you have a string which contains the characters, and you have to find a substring without any duplicate characters, right? So a string can contain letters, digits, symbols, any spaces. Okay, so let's try to move to the basically problem. Okay, this is also similar problem. I'll just explain it fastly. So just try to think, this is also like a very easy problem, I would say, once you understood the non-duplicate character. Find a maximum length substring. This is a simple problem. So once you understood the previous one, this one would have been very straightforward, just trying to explain how you can tackle this. So let's say you have a string which is nothing but A, B, D, E, A, F, G, F, H, right? So let's say this is the one, right? So now what we are trying to say is you have to find a unique substring, right? So your substring with a unique characters, it should not have any duplicate in simple terms. So what you keep is your basically current string, I would say, in simple terms, and the k will keep k equals to 0. Okay, and I would say current string, better word I would say for this is yeah. Now let's k equals to 0, which is nothing but a substring starting point, right? Now let's say move to the k equals to 0. K will keep it for that, and will keep a sort of an array, or you can say vector in C++ if you use that. So which will have the 256 length, which will be your ASCII characters to cover all. Okay, so basically it's like you have an array of size 256 initialized with a 0, just to maintain a mapping which all are we have visited, so that when we visit the same character again, we will be able to tell, yeah, this is already visited. Now moving to the next, we will make it duplicate, so we need to squeeze the which we did earlier, right? Something similar. So what I'll say is, think like a map, which is nothing but array can be like indexed map, right? Which will have 0 as your index, which is key, and the value will be whatever you store. So similar way, I'm just giving the analogy for that. So let's say k equals to 0. Now let's move to I equals to 1, I equals to 0. Your k is still 0. What you have in this array is for the a, right, which is nothing but let's think in the simple terms. For the a, right, for the a you can compute index int of a, which will give the integer value of the a. Okay, so let's assume for the a, whatever the index will come, will mark it as a 1. Now I equals to 2, right, I equals to 1, sorry, k equals to 0. So first we check if a is already present in this array or not. It's not there, then we marked it and we moved ahead. So I equals to 1, k is still 0. B, we've again checked if the array has a b already or not. It's not there. So what array will have a point 1, b point 1, k is still 0, I equals to 1. Now moving further, right, I equals to 2. Now in this we have a d. So what it will have, a1, b1, d1, right? K is still 0. Now let's move to e, right? Similar, I equals to 3, a1, b1, d1 and e1, right? So k equals to 0 still. I equals to 4. 4 is your a again. So a already exists, right? So for moving that, right, so this is one of the unique array we got, substring we got, sorry, and that has a unique characters. So which is the length of, what will be the length for this? So length is nothing but your basically whatever the I you have, and if you just subtract minus k plus 1, so I is 0, I is 4, k is 0, so this is a 4 length sum. So your answer here becomes 4. This is one of the substring I got with a 4 length, which has a unique characters, right? Now I equals to 1, right? So which is nothing but your, so here is 3 minus 0 plus 1, which is 4, right? Because if you do, right, because you have to compute it from the lengths of previous, right? So if you, like, if you're at 4 and you found, so what will be the formula will become, because till I minus one character only you have to pick minus k plus 1. So what 1 to 1 cancel out, I minus k is your answer, which is nothing but a 4 minus 0 is 4. Simple. That's how I have written that. Okay. So now let's move to the 4 length. You got it. Now what you have to do is you have to squeeze it. So further k equals to 1, your a becomes 0, b is still 1, d is still 1, e is still 1. So once the you have to keep iterating for the like squeezing or sliding the window till that point, whatever the current index, which is nothing but I equals to 4, whichever character is there at I, the array should not have, then only it will become unique, else it will become a duplicate, right? So you became 1 at k equals to 1. Now your array is a0, b1, d1, e1. So this is one of the unique array now again, right? So we can put a to 1 because for iterating a fourth it will become 1, right? k1 and then the remaining will same, right? Now fg. So next character is I equals to 5, a1, b1, d1, e1, f also 1. Sorry. And k is still 1. So this is also one of the unique. So in this, whatever the length, your answer can be like whatever 5 minus 1 plus 1, right? So 5 in short, right? 5 length subarray you have. Now I equals to 6, we move, right? So 6 has a basically g, right? So a1, b1, d1, e1 and f1 and g1, right? And k equals to 1 and answer equals to 6, right? Because we have the 6 characters, right? So a, b, d, e, f, g, right? Now let's go to the I equals to 7. So 7 again duplicate character comes, which is nothing but your basically fg, fh, right? So f becomes again a duplicate. So your answer is this. Now you have to move the k, right? K to a still 1, b still 1, b. What was the second character? Was it a b? Yes. So b is becomes 0 because we have moved. D equals to 1, e equals to 1, f is still equals to 1, right? So k equals to, and answer till this point is still 6 because the earlier one is maximum substring, right? So if you see, right, till what point of time this k will move, if you see this like example, right, of the string, right? So we are at here and your k is here, I is here. So it has to cover all these to make this array unique, right? So it has to cover all these. So what will be the character finally? So it will come till the point of, let's say, 0, 5, right, and 6. So it has to come till 6 for it to become, k will become 6, I is still on 7, and here we'll have f1 and g1 only, right? Because it has to be unique. So for that condition to be basically satisfy, we have to slide the window. So f1 g1 we have I equals to 7 and answer is still 6 because this is not an sum. K equals to 7, k is 6, sorry, I equals to 8, we move f1 g1 h1, right? And answer is still 6 because that maximum you are taking, and this is the end of the array. So what is the, so in this you saw, right, for f2, for the I pointer to be moving, right, for I, the whatever the 7th index f we had, right, this f to be inserted in that array, we have to slide the window at that particular point of time so that like there shouldn't be any duplicate. So we have to basically forward that k pointer to the till the point where we don't have any duplicate character which is coming like for iterating over the f, right? So f came, so you have to remove all the f's which are existing, so you have to restill g, then only your substring will become unique, right? That's the whole point. That's the slide we are talking about. Okay, so that way you can compute. Let's move to the LeetCode where I've already coded this also. So let's move to the code of this. I'm just trying to explain that. Okay, let's move. Yeah, so in this we have taken already 256, right? It's nothing but your basically, I would say 256 is, it's a ASCII character because it has covered like digits, lowercase, uppercase, and spaces and other things. So I covered all the ASCII. 256 size I have taken, and the 0 is the initial value I have put in. Answer is 0. Previous is nothing but your k, and character exist is the sort of working sort of your map, I would say, where I'm computing the integer index for this and just trying to see if it doesn't exist. I insert it. I try to get the current length of the unique elements, which is nothing but a I minus previous index plus 1. So, and once I have that, right, so then that will become my maximum answer because this is a current I'm moving in, right? And so till the point I'm inserting, that is my maximum, right? Once I stop, then I have to squeeze the array. So squeezing the array is a sliding, nothing but a, right, substring, sorry, right? So previous index whatever I had, once I found, let's say, duplicate f or duplicate a, so I have to squeeze till a such that the character exists for the current index should be there, so that I keep on making those character false and previous index I'm moving it. And once it doesn't exist in our char exist array, then once I come out of loop, I mark that as a exist because I'm iterating that character in the current index, right? And the final answer, whatever the thing that we have in this, will be the answer, right? So let's submit this. So if you see this, 1 second. Yeah, so this is submitted, right? I think so. Basic core concept, hope you understood what I'm trying to explain here. These are easy medium problem, I would say, where you should learn how to apply. The core concept is how to apply sliding window. So the problem where you have to minimize or maximize such that you need to find a subarray, substring, or you need to find a like optimal sum or something, right? By you have your back pointer, you have your current pointer, and just trying to see, you reach till a point and then you see ki I have inserted some extra element, I need to back pointer, I have to move forward so that I can minimize or maximize whatever the goal is, right? That can be done from that point, right? So that's the whole point of this concept, and we'll try to solve some advanced problem in the same concept in the harder problem side. So these are easy to medium. Now we'll go medium to hard side in the next video. Hope you like this video. Let me know if you have any doubts, and please like, comment, share the video. We'll keep on making many more such videos where we'll try to cover all the basic concepts from basic to advanced.